using Earth Imager 3D. This is a 3D version of Earth Imager. Okay, this is a 3D version. How to make sure that your lines are in parallel. Okay, so according to the model I want to create right now for some lines, and to show you how these lines are. So I'm going to give you let me use this white space to show you the sketch of what our lines will look like. Okay, so my first line is gonna go this way. Okay, second line, because of my time, I'm going to use some lines. I'm not going to use all the lines, so I'm going to use some lines that relatively look more parallel than the others. And these lines are line 5, line 4, okay, line 5, 6, 7 and 8. I'm going to use my 5, 6, 7 and 8, these lines. This one's right here. They look more parallel than the other. You cannot see the model I'm using right now because it's on my phone. So after running your lines in the field, take the coordinates of the start and the finish of your lines. When you take those coordinates, then you put them on Google Earth. Make sure that your lines are straight so that you can know how straight your lines are. So I will explain to you what I'm doing here. Show you how to use Earth Imager 3D to form a 3D model from 2D parallel. So already I've shown you how to save the STG data in your Earth Imager 2D. Okay, so make sure you save the STG data for all the lines and make sure that those lines are parallel, like I explained in the end of the video. Make sure that those lines are parallel. Make sure that those lines are parallel. Make sure that their start and finish are almost at the same. That the start and finish are aligned, are well aligned, so that your line will look good. So you can picture real life, have a real life model. So go to combine parallel 2D. Okay, the 2D that you created from your 2D Earth image. So combine parallels. So you first of all add the first line. Like I said in the other video, I said we're going to do just for line 5, line 6, line 7, and line 8. Let's add a lot of okay, this is like this now. So I take line 5, because line 5, line 6, line 7, and line 8 are very parallel and their ends are almost at the same horizontal, so they'll give me a better model. So add line 5, add line 6, make sure they are in order, but this one is showing the next one, and add line 7, add line 8. I will use these 4 lines to explain to you what I mean. So now I've added the 4 lines. So their approximate distances. Let me use 20 meters as a point. So this is 0. This is 20. From 0 to 20, this is their horizontal separation. Okay, their special separation between each parallel. So from 0 to 20, from 20 to 40, because we're using 40 distance between 20 meters difference between them. So you see from 0 to 20, from 20 to 40, from 40 to 60. So they have 20 meters between them. So you combine. If you ask it to combine, to name the combined file, so name them line 4, line 5, sorry, line 5, 6, 7, 8, so I can recognize it. Okay, save. So we've saved, then we close. After you've closed, next thing you do is to make sure that your settings are okay. Check your settings, and then do you want to remove all negative resistivity? Let's remove the negative resistivities. Okay, if you want to keep all the data, you can keep all the data, but I want to remove them. Okay, let's try to use layer. Okay, a layered model. Let's try to use a layered model because the underground is layered. And where the survey is done, we basically have two major layers: the Abakaliki sandstone and the Ezako shale. Ezako shale or Asriva shale, one of them, I can't remember. So number of iteration, let's try and increase it to 5. And then I think it is stop at 3. So you apply the setting. Okay, let's check out IP inversion. Let's check out IP. Make sure your IP is active. Remove all IPs, all negative IPs. Okay. Touchability. Put it in layer 2. Maximum IP data. Put at 1000. Minimum conversion effect. Now, load the data. Load the combined 3D. That's it. Open. So you see now, from this you can see that the line 1 is at the bottom. That's the line 5 is at the bottom. Line 6 is following. Line 7 is following. Then line 8. This is not the way my lines are in reality. In reality, 1 is at the top. That's 5 is at the top. Okay, 6 is following, 7 is following, and 8 is following. So make sure that you do the right thing. So what I'm supposed to do is to add line 5 first, because line 5 is one that is at the north. Okay, so you have to be very, very careful. So start inversion, deconstruct inversion, and run inversion. The inversion is running. You wait for it. Depending on the speed of your system, the inversion will go slower or faster. So you see, it's giving me, it's showing a layered model because we use a layered model, not a homogeneous model. So you wait for it as it's running. Is still processing your inverted resistivity image. So this is the model. It's coming out. So make sure that the spacing between each of these lines is what you have in your field. So I use 20 because relative to the length of the lines, I figured out that the distance between them is 20 meters. Okay, so I'm processing this data for someone, so they give approximately 20 meters between these 4 lines. So it's possible to have a line where you have 50 meters and the model will be wider than this to be more like a cube. You see, it's more like a cube line. Okay, so your IP now is running. You can see it's running IP. IP is the one running now. So as the IP is coming, okay, this is the IP now. This is the IP. Okay. The IP is ready. Alright, see how beautiful this looks. So this is what you have. So you'll be wondering where your inverted resistivity image went to. You will still see that soon. So this is you can hold down your left mouse button to rotate. Okay, to rotate. Okay, so you can use your right mouse button to drag in and drag out to zoom. Okay, to zoom. Then use your left button to rotate, to hold it at any point and rotate to view. So from here you see that this is that line 5, which I told you is supposed to be at this first frame. So line 6, line 7, line 8. So this is a low chargeability body, which is not a target, so it shows that there's no mineral ore here. But right under here is showing us that there is something happening here. There's a high chargeability here, so probably, and which is even shown under this place. So this is probably an intrusion, a metallic ore. Now you see across here the chargeability is high. Okay, so that's that. Alright, so you go to the view. When you go to the view, you can view your measured point resistivity. Okay, you can view your inverted resistivity model. Don't mind it, say okay and click it again. Okay, that's it. So it shows you your resistivity model. Is low at this point. You can also view your static slice resistivity model. So you want to slice this surface and look at it. You want to slice it from any angle. You can slice it along Y. You can choose the number of slices you want to take. So this is Y axis, this is Y axis, this is X axis, this is X axis, this is Y axis. Okay, sorry, this is X axis. Okay, it's numbered this way, but this is how the slices will go. So this is X axis, but the slices will go along the X axis. This is Y axis, so the slices will go along across the Y axis. This is Z axis, so the slices will go will cut through the Z axis. Okay, so if you choose X slices here, if you choose X slices, so it's going to slice it along across the X axis. So it's going to slice it like this, like a sliced bread. It's going to slice it this way. See the way my mouse is going, it's going to slice this way. So let's choose S and say 10 slices, and let's take 8 slices. Okay, and say okay. Don't mind it, say okay. Click it okay again. So you see it slices are along there. And so with this you can actually view through and see how your changes go along. Okay, you can view through them and see how your changes go. Okay, so go back to view. You can take dynamic resistivity model, say okay when this happens, and do it again. Dynamic slide. So using your left button, you can hold down the turn. Then when you're holding a plane and you use your right button of the mouse, you can slice the plane up and see the changes. You can hold any slice and see the changes. Okay, so you see how the bodies are changing. So this will help you to correlate along various axes. So I just bent this. So if you hold it at the edges, it can bend. It can cause it to bend. So alright, so slice them on. if you put the mouse outside, you zoom in and zoom out. Then your right button is to rotate. Okay, and look, have a good look. All right. So I didn't show you another slide in that static slide. I didn't show you Z, I didn't show you Y, but let me just show you one of it. Let me show you Y. And restore. It's okay. It's not showing, just click it to show. So you see how it looks like. This is what it looks like. So it has now been sliced along the y-axis. Use your right button to zoom and zoom out. So does that for this. So you can also do the same thing for IP and look at the different distance. So your 3D contour, all the things you do here, you can also do for the IP. You can also do for some other things. Your 3D contours, okay. Do it again, 3D contours. Choose. I don't want to show the little ones. Okay, you can just take an interval. Let's apply an interval. Okay, you can apply an interval and look at this. Can help you especially. Okay, let me do this in terms, you know, in Resistivity when you're looking for an or, someone that is looking for an or, in Resistivity you're focusing on the low resistive bodies, so you can tick out all the high resistive bodies and say apply. Okay. But let's go to IP. In IP, 3D contours model for IP. Okay. View 3D contours for IP. Okay. So in IP we are taking high traceability. Okay. High traceability. So let's focus on the one that are very high. Let's focus on the high one. Okay. And say okay. This area is located. This is 2. Let's increase it. Let's increase it. Okay. Let's start from 105 down up to 312. Okay, see, these are places where you can possibly find all minerals, because this is where you have high. So within this space and within this space, you have high chances of finding conductive bodies. Alright, so this is what it looks like. So you can tell someone to drill at this point and target this. These are prospects now. Okay, so these are prospects. Okay, so what more? You can also change the image properties of volume rendering. You use texture mapper to give it a good texture, so image is sharper. You can choose any other kind of volume rendering. Have something nice. Okay, I'm going to stop here for the 3D.